Hello guys, it's Godson and this is Wits Lounge, Learning Made Easy. Today, we are going to be discussing an important concept, and that is solutions and solubility. Mind you, we are going to be sharing this study into different talking points, which is going to be found in different videos. So please, do like and subscribe to get updated as the videos pop up. Now, however, let's see the talking points or the major talking points for this study. First of all, we are going to be discussing mixtures and the different types of mixtures. We are also going to get into the properties of the mixture types. We are going to discuss solubility by defining it and talking about the factors that affect them. We'll talk about solubility formula, solubility curve, and solubility product. These are the different things we're going to be discussing in this study. As I said, it's going to be shared into different videos, so please do like and subscribe so you get updated as they pop up. In this video, we are going to concentrate on understanding the mixtures, having solution as the most important mixture for this study. Okay, let's get into it. What is a mixture? A mixture is a combination of two or more substances which are not chemically bound together. I take it again. A mixture is a combination of two or more substances which are not chemically bound together. So once you combine things together and there is no new product formed by a chemical reaction, that's a mixture. Now, there are three major types of mixtures. What are they? Number one, you have solution. Number two, you have colloidal solution. And number three, you have suspension. I take it again. Number one, you have solution. Solution is more like also referred to as the true solutions. The colloidal solution, which is the second one, is the false solution. Yeah, true and false. And then the final one is suspension. Okay, so with all those things listed, we'll start with the first one, which is solution. What is a solution? A solution is a homogeneous mixture of two or more substances. I take it again. A solution is a homogeneous mixture of two or more substances. So somebody might just be looking at it and be like, okay, you said combination. So does it mean that ofe egusi? Yeah, the Nigerians will understand what I'm saying. Or maybe ogbono soup. Or the edikaiko is a solution. No, please. The emphasis in the definition of solution is homogeneity, which means that they are all in one phase. They are all together, more or less, they have become one. Good. So with that said, you find out that the egusi soup that you're talking about is not homogeneous because you have large lumps of meat and every other thing inside. But let's not talk about that. The point is this: a solution has to be homogeneous. Now, having said that, we would get into another important aspect of this study, and that is the types of solutions with respect to the quantity of solute. Mind you, every solution is made up of a solute and a solvent. The solute is what is being dissolved, the solvent is what dissolves. For instance, if I have sugar and water, the sugar is a solute, water is a solvent. Back to what we were discussing. I said we are going to be discussing the types of solutions with respect to the quantity of the solute. There are three of them. The first one is an unsaturated solution. The second one is a saturated solution, while the third one is a supersaturated solution. I take it again: unsaturated, saturated, and supersaturated. Let's start with the unsaturated. From the definition of the term, you look at the word unsaturation as not filled. So when you think of unsaturation, what do you think? Not filled. So an unsaturated solution is a solution that can still dissolve more solutes at a particular temperature. So you notice this, that once you have, for instance, I tell you that a cup of water can only dissolve 5 cubes of sugar, maximum 5 cubes of sugar. And then I include or add 2. Is it saturated or unsaturated? Obviously, it's unsaturated. Why? Because you can add 3 more to make it 5. So any solution that is unsaturated can still dissolve more. That's the point. We go to the next one, saturated solution. The term saturation has to do with filled. When you say something is saturated, it means that it is filled. And what do we mean? A saturated solution is a solution that can dissolve more solutes, even in the presence of undissolved solutes at a particular temperature. So why did I have to say that? You would notice that if, for instance, I have a class that can accommodate only 50 students and 1,000 students come to school, the number of students that will get into that class would be exactly 50. Not minding the fact that you have 1,000, the only ones that will get in is 50. So once it is filled, it is said to be saturated. Not minding the fact that there are others waiting outside. it doesn't matter. A saturated solution is the one that contains the highest number of solutes in which that solution can accommodate at that particular temperature. Then we go to the final one, supersaturated. Here, you should be able to guess what that means. So, where you have a whole lot of solutes, more than required for a saturated solution, that is what you refer to as a supersaturated solution. So I define it again. A supersaturated solution is a solution that contains much more solutes than that required to saturate a solution at a particular temperature. Having said that, we have described the different types of solutions. And now we're going to talk about the properties of solution. What are those things you look out for in a solution and you'll be like, yeah, that's a solution and not a colloid, or that's a solution and not a suspension? What are those? The first point is that every solution is homogeneous. Yes, every solution is homogeneous. So whenever you think about a solution, you think of homogeneity. The second point is that the particles or constituent particles of a solution is usually less than 1 nanometer in diameter. So which means that the diameter of the constituent particles of a solution has to be less than 1 nanometer. And when I say 1 nanometer, I mean 1 times 10 raised to the minus 9 meters. That's quite small. That's like 0.000. You get what I mean. But let's continue though. So it's quite small, and that's actually one of the things that accounts for its homogeneity. Then we go to the next one. The third property of a solution is that it does not settle. It's stable. It doesn't settle. When you for instance, bring a cup of water and you include sugar and you kind of mix it up, you will notice that the particles of the sugar would never go down to the base. Unlike a situation where you have chalk in water, if you put chalk in water and keep it for a while, you notice that the chalk particles will eventually settle. It means that chalk in water is not a solution. So have this in mind, that once it's a solution, you will not have the particles settling. Take it again. The third property of a solution is that the constituent particles of a solution do not settle. They are not going to sediment. That's what I mean when I say settle. Sedimentation does not occur in solutions. The fourth property of a solution is that solutions cannot be filtered. Why can they not be filtered? It's simply because the particles are too small, hence everything passes through the filter paper. So have this in mind, that solutions cannot be filtered. And then finally, the fifth property is that Tyndall effect does not occur in solutions. What do I mean by Tyndall effect? Tyndall effect is the scattering of light. The scattering of light. Take for instance a diagram on the board. Let's consider this, where you have a particular, and then let's use the yellow color for the particles. And then you have another solution, for instance, let's use the white color. Now, describing Tyndall effect is the scattering of light. First of all, we should understand that a principle known as wave-particle duality of light, which actually describes light as both a particle and a wave. So, to understand Tyndall effect, we're going to be considering light as a particle. Now, if light is a particle and tends to collide with large particle, it changes the direction of the photon. But when it collides with very small particles, there is no change in direction. So imagine this is a false solution, and here you have a true solution. And you have a particle of light or light ray passing through. If it hits this particular large particle, it distorts the direction. Well, here, because of the fact that you have small particles, it doesn't alter or change the direction of the light ray. So you have that Tyndall effect is not exhibited in your true solutions. However, it can be exhibited by your false solutions. Why? The particles can change the direction of the photons. So when you talk about Tyndall effect is the scattering of light as a result of distortion of the direction of the photons. So once the direction of the photons or light ray is changed, that's what we refer to as Tyndall effect. So you could have that light rays could be traveling, and then they go through here, hits this, changes, goes through here, hits this, changes direction, goes through here, hits this, changes, goes through here, hits this, changes. So that scattering of light rays into different directions is Tyndall effect. And you notice that that property is not exhibited by a true solution. Why? Because the particles of true solutions are quite small, they are infinitesimal. With that said, we are done with the properties of true solution.